All right, let's talk about one of the biggest, most frustrating problems with AI right now. Today, we're going to fix it. We're diving into a framework called RAG, which is all about stopping AI from just making things up and turning it into an expert tool you can actually rely on. Let's get into it.
So I'm sure this has happened to you. You ask a chatbot a question, and it gives you this answer that sounds so smart, so confident, but it's completely 100% wrong. It's a massive problem, right? It's really holding AI back. So the big question is, why on earth does this keep happening? Well, there's actually a name for this: hallucination. And this quote here nails it. Large language models, or LLMs, are designed to be creative and generate human-like text. But when they don't know an answer, they often just fill in the blanks with things that sound good. They invent facts. And for any serious company trying to use this tech, that's not just a funny quirk, it's a deal breaker.
And hallucinations are really just the tip of the iceberg. These standard LLMs have some pretty serious limits. For one, their knowledge is frozen in time. They don't know anything that happened after their training data was collected. They also give these really generic answers because they have no specific context. And critically, they know nothing about your company's private data. You can't ask them about last quarter's sales report because they've never seen it.
So, how do we fix all of this? Well, there's an incredibly clever solution, and it's called Retrieval Augmented Generation, or RAG for short. And honestly, the best way to think about it is right here on the slide. We're basically giving the AI an open book exam. What RAG does is it stops the LLM from just guessing. Before it's allowed to generate a single word, the RAG system first goes and retrieves relevant, up-to-date information from a knowledge base that you control. Think of it like your company's internal documents, recent news, anything you want. This really is the perfect way to think about it. A normal LLM? That's a student in a closed book test. It's working purely from memory, and that memory is months, maybe even years old. But a RAG-powered AI, that's the student who gets to bring the whole library to the test. It can look up facts and figures on the fly, making sure its answers are actually based on something real. Okay, so that sounds great in theory, but how does it actually work under the hood? Let's pull back the curtain and break down how you get from just a pile of raw data to a smart, accurate answer. It's a really logical process. It all boils down to these 5 basic steps. It's like a data pipeline, really. First, you gather up your knowledge. Then you chop it up and make it searchable for the AI. Then, when a user asks a question, the system finds the right piece of info and hands it over to the LLM to write a nice answer. Let's dig into the most important parts. First things first, data chunking. Look, you can't just throw a giant 100-page PDF at the system and expect good results. It's way too slow and clunky. Instead, you chunk it. You break it down into smaller, focused pieces, like individual paragraphs. This makes sure that when the system looks for an answer, it finds a very specific, very relevant snippet of text. Next up is the real magic, embeddings. Computers don't read words like we do. They see numbers. So an embedding is just a way to turn each chunk of text into a special list of numbers, a vector, that captures its actual meaning. This is so important because it allows the system to search by concept, not just keywords. You could ask about time off for new parents, and it could find a document that only uses the words maternity policy. This is all handled by super-fast vector databases like Milvus, which are built for this kind of semantic search.
So, if you remember just one thing from all this, make it this. It's the RAG mantra. First, you retrieve the facts. Then, and only then, do you generate the answer. Retrieve, then generate. It's that simple, and it's what makes the whole system so reliable.
All right, we've got the how. But what about the so what? Why is this approach such a total game changer? Let's talk about the real-world payoffs, because honestly, they are huge.
The benefits here are just so clear. With RAG, your AI's knowledge is always current. Hallucinations practically disappear because the model has to use the facts you give it. You can even build in trust by making the AI cite its sources. And maybe the biggest one of all, you can make a general AI into a highly specialized expert in medicine, law, whatever, without having to do any crazy expensive retraining.
And this chart right here, this tells the whole story when it comes to cost and speed. Just look at the difference. Updating a RAG system means just adding a new document to your database. It's fast, it's cheap, but retraining an entire LLM, we're talking tons of money and weeks, maybe even months of work. RAG is just way more agile. Okay, quick pivot. For all you engineers, architects, or anyone heading into a tech interview, listen up. Knowing how to talk about RAG can be your secret weapon. Let's walk through how to absolutely nail that system design question. So picture this. You're in a system design interview, and they hit you with this exact prompt. This is a test. They don't just want to hear, I'd use an LLM. They want to see if you know how to build a smart, reliable system. Your answer needs to be RAG. So here's your winning answer. You lean in and say, I'd build a RAG architecture. And then you lay it out. First, we'll index all the documents into a vector database for efficient semantic search. Second, we'll build a modular system with a retriever and a generator. And crucially, and you say this part with confidence, we'll use prompt engineering to force the LLM to ground its answers only in the retrieved sources and to cite them. Boom, you've just shown you're an architect, not just a user.
When you boil it all down, it's this simple. RAG doesn't just give an AI a better memory. It gives it a library card, an all-access pass to a library that you control and that's always up to date. It makes the AI smarter, more accurate, and a whole lot more useful. And that kind of leaves us with a pretty deep question to chew on, doesn't it? If an AI can instantly find, understand, and explain any fact we've ever written down, what does it even mean for us to be knowledgeable anymore? Is it about what you can remember? Or is it about knowing how to find and use the right information? That's a question we're all going to have to figure out, and probably sooner than we think.